Stop me if you've heard this one before. You watch a 20-minute tutorial on YouTube about building an AI automation agency. The host is charismatic, the logic seems sound, and the promise is incredible. Build a lead generation bot, a customer support agent, or a content generator in minutes using N8N. They drag a generic webhook node onto the canvas, connect it to OpenAI's GPT 5.1, and maybe hook it up to a simple HTML form or the native N8N form trigger. They hit activate, show you it working once, and say, "Congratulations, you're ready to sell this to clients."
If you follow that advice verbatim, you aren't building a business. You are building a financial time bomb. What those tutorials forget to mention or simply don't have the time to explain is that the native N8N form URLs and basic webhooks are public endpoints. They are completely exposed to the open internet. Here is the nightmare scenario. You deploy this form on a client's website. 2 days later, a simple scraping bot, not even a targeted hacker, just a dumb script crawling the web for input fields, finds your form. It doesn't care about your business logic, it just starts posting data. 10 requests per second triggers your N8N workflow. Every single workflow triggers an API call to OpenAI or Anthropic. You wake up the next morning not to a list of new leads, but to a $5,000 bill from OpenAI and a suspended account because you hit your usage limits in 3 hours. Your client is furious, your infrastructure is crashed, and you are liable for the cost. Today, we are doing a deep dive into the security architecture of N8N automations. We are going to tear down the tutorial-style setup to understand exactly why it's insecure. Then, we are going to rebuild it the right way. We will look at how to stop bots from slamming your AI, how to protect your webhooks, and why you need to decouple your front end using professional form builders with domain restrictions, email verification, and rate limiting. This is the difference between a hobbyist script and a production-grade engineering solution. Let's get into it. Part 1. The architecture of vulnerability. To understand the solution, we first have to respect the problem. Let's look at the technical architecture of what I call the YouTube happy path. In N8N, the primary way to trigger a workflow from the outside world is the webhook node. When you set this up, N8N generates a URL. It looks something like your-n8n.com/webhook/long random string. In many recent updates and tutorials, creators showcase the N8N form trigger. This is a handy feature that auto-generates a UI for that webhook. It's amazing for testing. It's amazing for internal tools where you are the only one with the link. But here is the critical failure point. Obscurity is not security. Many developers, especially those coming from a low-code background, assume that because the URL has a long random string at the end, it is hidden. They assume that if they embed this form on a specific page of their website, only people visiting that page can find it. This is technically false. When you place that N8N form on a website, usually via an iframe or a direct link, that URL is visible in the source code. If you right-click and inspect element on the page, the direct endpoint to your automation is sitting right there in plain text. Bots and scrapers do not browse websites like humans do. They don't look at the pretty colors or read the copy. They parse the HTML. They look for form tags, iframe tags, and input fields. When a bot finds an endpoint that accepts data, it will often try to spam it with generic payloads to see if it can exploit it for spam relay, SQL injection, or simply to map the network. Even if the bot isn't malicious, it creates noise. But if the bot is malicious, or if you are targeted by a competitor, they don't need to visit your website to trigger your automation. Once they have that webhook URL from your source code, they can bypass your website entirely. They can open a terminal and use a simple curl command or a Python script to send thousands of requests directly to your N8N server. The cost of the happy path. Let's talk about the specific financial vector here. In a standard automation, your webhook receives text, and you immediately pass that text to an LLM node, say GPT 5.1 or Claude Opus 4.5. These models are priced per token. If a bot sends a massive block of nonsense text to your webhook and your automation passes that nonsense to OpenAI, OpenAI will process it. They will charge you for the input tokens, and they will charge you for the output tokens as the AI tries to make sense of the gibberish. Let's do the math. Suppose a bot attack sends 10,000 requests in an hour, a very small number for a botnet. If each request costs you just 3 cents in API fees, that is $300 gone in 60 minutes. If it runs all night, you're looking at thousands of dollars. Furthermore, there is the infrastructure cost. N8 is efficient, but it has limits. If you are self-hosting on a small DigitalOcean droplet or a basic AWS EC2 instance, 10,000 concurrent executions will crash your server. Your legitimate workflows, the ones running your business, will fail because the CPU is pegged at 100% trying to process the bot spam. So the YouTube tutorial setup gives you 2 points of failure: uncapped financial liability on the AI API side and a denial of service risk on the infrastructure side. The fallacy of client-side validation. I often hear people say, well, I'll just add some JavaScript to my website to validate the input before sending it to N8N. This is the second most common mistake. Client-side validation is for user experience, not for security. If you write JavaScript that says only allow email addresses from this domain or ensure the text is less than 500 characters, that code runs in the user's browser. Remember what I said earlier? A sophisticated attacker or a bot script does not use your browser. They send HTTP requests directly to the webhook URL. They bypass your front end entirely. Therefore, any security rules you put on your website's front end are completely invisible to a direct API attack. You cannot secure a backend workflow from the front end. You must secure the gate itself. Part 3, the enterprise solution, decoupling and gating. So, how do we fix this? How do we place a form on a client's website without exposing the raw N8N webhook and without risking an infinite AI bill? The answer lies in decoupling. We need to stop thinking of N8N as the front end. N8N is your backend logic engine. It should never talk directly to the unauthenticated public internet if money is involved in the execution. We need a middleware layer. We need a bouncer at the door. This is where professional form builders come in. I'm talking about tools like Tally, Typeform, Jotform, or Fillout. You might think, why pay for a form builder when NN has forms for free? You are paying for the security layer that sits between the user and your wallet. Here is the robust architecture we need to implement. It consists of 3 defensive layers: domain restriction, verification, and rate limiting. Domain and referrer restrictions. Professional form builders allow you to embed their forms into your website. However, the high-end ones offer a feature called Allowed Domains or Embed Protection. This setting ensures that the form will only load and accept submissions if it is embedded on yourclientwebsite.com. If someone tries to take the direct link to the form and paste it into a browser, it will show an error. If a bot tries to load it from a different source, it gets rejected. While this isn't bulletproof, headers can be spoofed, it eliminates 99% of drive-by bot traffic that is simply scanning for open forms across the entire internet. It drastically reduces the surface area of the attack. Layer 2, the verification gap. The next layer is verifying that the human is actually a human and that they own the email address they are using. In the naive N8N setup, the automation runs the moment the button is clicked. In a secure architecture, we introduce a handshake. When the user submits the form on your professional builder, let's use Tally as an example, we do not trigger the heavy AI workflow immediately. Instead, the form submission triggers a lightweight, low-cost workflow. This workflow does one thing. It generates a unique token or a magic link and emails it to the user. Why do we do this? Because sending an email via SendGrid or Postmark costs a fraction of a penny. Sending a prompt to GPT-5 can cost significantly more. By forcing an email verification step, you ensure 1. The email address is real, 2. The user has access to it, 3. A bot cannot simply flood the form to drain your AI credits.
What? This can't be right. A botnet attack cost me how much?
Because the AI only runs after the link in the email is clicked. If a bot fills out your form 1,000 times with fake emails, the worst that happens is you send 1,000 verification emails to nowhere.
Oh
Your
yeah, that's
OpenAI
how we
bill
do.
remains at 0. Layer 3. Rate limiting and CAPTCHA. Professional form builders have native integration for CAPTCHA, like Cloudflare Turnstile or Google reCAPTCHA. This is your first line of defense against automated scripts. It challenges the user to prove humanity before the data ever leaves the browser.
Furthermore, tools like Jotform or Typeform allow you to set unique submission rules. You can limit submissions to 1 per IP address per day or check cookies to prevent spamming. If you try to build this logic inside NN, you have to maintain a database of IP addresses and timestamps, which complicates your workflow and consumes server resources. By offloading this to the form builder, you are letting their infrastructure absorb the bot attacks, keeping your NN instance clean and performant. The secure implementation walkthrough. Let's walk through exactly how to build this secure stack, step by step. We are going to use a hypothetical stack of tally forms for the front end and NN for the back end. Step 1. The secret handshake. The most critical part of this setup is securing the connection between tally and NN. Even if you use tally, tally still needs to send a webhook to NN. If someone finds that webhook URL, we are back to square one, right? Not if we use a secret token. In your NN webhook node, you will not just accept any data. You will look for a specific header. Let's call it XAPI secret. In Tally or your chosen form builder, when you configure the webhook integration, there is usually an option to add custom headers or hidden fields. You will generate a strong random password string like a UUID and place it in the form builder's webhook configuration. Now, back in NN, the very first node after your webhook trigger should be an if node or a switch node. The logic is simple. Does the incoming header XAPI secret match my generated UUID? True, proceed to the workflow. False, terminate immediately. Return a 403 forbidden response. This means even if a hacker finds your N8N webhook URL, they cannot trigger the workflow because they don't know the secret token stored inside your Tally account configuration. Step 2. The data sanitization. Once the request passes the secret check, do not pass go, do not collect $200, and definitely do not send the text to OpenAI yet. Use an N8N code node or a text manipulation node to sanitize the input. Truncate the input length. If your form asks for a business description, hard cap it at 1,000 characters. Why? Because a common attack is to send a 50,000 character string to try and overload the memory or max out the token context window of the AI model. By truncating the input before it hits the AI node, you cap your maximum financial exposure per execution. Step 3. The rate limit, Redis or built-in. For the ultra-paranoid or high-traffic setups, you should implement rate limiting inside N8N. You can use the native wait node or, for a more robust solution, a Redis node. When a request comes in, check if the user's email or IP has triggered the workflow in the last 10 minutes. If they have, route the workflow to an empty end node. Do not respond, do not process. This prevents the race condition attack, where a user clicks the submit button 50 times in 1 second. Part 5. Real-world scenarios. Let's look at 2 real-world scenarios to illustrate the difference this makes. Scenario A. The naive agency. You build a free SEO audit tool for a client. You use a standard N8N form connected to GPT-5.1. You embed it on their WordPress site. A competitor hires a black hat SEO firm to attack your client. They point a botnet at your form. The botnet submits 50,000 requests in 2 hours. Your N8N server crashes due to CPU overload. Before it crashed, it managed to send 2,000 requests to OpenAI. You owe $150. Your client's site is slow because the N8N instance was hosted on the same VPS. You look incompetent. Scenario B. The secure architect. You build the same free SEO audit tool. You use Typeform with Cloudflare Turnstile enabled.
You configure the webhook with a secret token header. You set up the N8N workflow to truncate inputs. The same botnet attacks. Result? 1. Cloudflare Turnstile blocks 95% of the bots at the form level. They never even submit. 2. The 5% that get through try to submit. Typeform's rate limiting catches most of them. 3. A few requests make it to N8N. Your if node verifies the secret token. 4. Your truncation node cuts the garbage text down to 500 characters. 5. The AI runs a handful of times. Total cost? Maybe $0.50. Client perception? The system stayed up, the spam was filtered, and you look like a cybersecurity expert. Let's review. Automation is powerful, but power without control is dangerous. The ease of use provided by N8N is a double-edged sword. It lowers the barrier to entry, allowing anyone to become an engineer. But it also allows anyone to make engineering mistakes that usually take years of experience to learn. When you are building for yourself, hacking together a quick webhook is fine. But the moment you start building for clients, or the moment you attach a credit card to an API key, you have to stop thinking like a no-code builder and start thinking like a systems architect. Do not expose raw webhooks. Do not trust user input. Do not let your front-end talk directly to your expensive back-end APIs. Use a professional form builder. Gate your workflows with secret tokens. Verify emails before running expensive logic. And always, always assume that everything on the public internet is trying to attack you. If you implement these layers, form security, header authentication, and input sanitization, you can sleep soundly knowing your automation empire isn't going to bankrupt you overnight. Remember, security is fundamentally a balancing act between risk mitigation and operational efficiency. If we lock a system down to absolute zero risk, it becomes a digital brick, secure but useless because legitimate users cannot get any work done. Conversely, if we prioritize pure convenience to remove all friction, we leave the door wide open for attackers to compromise everything. The goal is finding the sweet spot where data is safe without paralyzing the business. This deep dive is by no means the only way to approach this automation, and different organizations may require vastly different strategies to find their own version of that sweet spot. If you found this deep dive helpful and you want to see me build this exact secure architecture live, step by step on screen, let me know in the comments below. Stay secure and keep building. I'll see you in the next one.